So now that we have our um, just the scene up and running, we need some stuff to put in there and some 3D modeling. So I like to do this in Blender. So I'm just going to create a new file and I'm going to hit W to get rid of the stuff here. W to scroll through our selection tool because I like the freeform selection tool there and select all those and delete it. But I guess it would work the same selecting as a box. I just find that freeform a little bit easier to work with. And um, just a cube or a sphere or any shape will work for a test here. I have some things already going. This is a point I'm going to make in the when I start the tutorial playlist about video game development. Is instead of saving the file, the end product, save the instructions on how to do it. For example, I have I created some Python scripts to add a human mesh in. Um, well, half of a human mesh because living things are symmetric and have a bunch of animals and stuff there. They're just saved as a Python script. So instead of saving the file that I had, I saved the instructions to the computer for how to recreate that. So there's half a human. I'll just apply a mirror modifier, add a mirror modifier, go ahead and apply that. So now it's a single piece and object shade smooth. So by saving those instructions, I have a little starting point for the character. I can add animations and then I just did half of it. So then I can add details and apply that mirror modifier so that the details carry over in symmetry, but just some sort of starting point. This will work for a starting point for testing. I think would be okay without a lot of animations or anything. I'm just going to give it some a material, so it's not a generic mesh. So on the materials tab, a new material, and just something sort of skin color. So I'll select choose a new base color. Somewhere over here should be something kind of matches the color, similar to the color of my skin. Oh, not up there. That'll work. That looks like a human skin-ish color. Oh, that looks awful yellow now that it's on there. Um, Maybe something lighter than that. More red in it. There we go. That looks like a skin. Kind of matches the color of my skin. Good enough for testing. So have that on there. Um, but Panda3D won't work with the Blender files directly. There is a converter, but on the latest version of Blender, if you weren't familiar with it, there used to be a game engine here, and they kind of dropped the game engine because there's more popular ones and focus solely on the rendering and animations and things like that. Uh, and just expected that to be used with other game engines. So there is a conversion for Blender into Panda 3D, but they are a little bit behind on the updates for the latest updates to Blender. So if you have the latest version of Blender, that won't work, but there's lots of file types that will work. The one I was going to use the uh, GLTF, probably a GLB file, one of those. But one thing we want to make sure if we're going to use a GLB file, just another format of 3 dimensions, is make sure if you click over on the shading tab, make sure the principal BSDF node is connected to the surface. So that's what should happen by default, but if not, just add the shader principal BSDF node and make sure it's connected to a material output surface. But that should happen by default, so that shouldn't be a big issue. But just to confirm that it's there. And if I already have this from previous projects, which is a point I'm going to make elsewhere, is don't save the file, the final version, save the instructions on how to get there. So this was actually saved as a Python script, which I have on my GitHub Maybe I'll leave a reference to it, but it's actually a Python script for the instructions to make that, not just saving the final versions. So then I have a really good starting point and save a whole lot of time with proportion, something that's already proportioned and laid out correctly, and all the seams are in place, and it's ready to start with. But since you probably don't have that, if you don't have something like that, a cube or a sphere or anything to work in a test. But we need to export it into a format that will work in Panda3D. And the GLTF, that format will work. So just export one of those to the folder we're working in, Panda3D test. And under geometry, make sure UVs and materials are selected, because you definitely want to make sure it knows the colors and textures and all that. So make sure both of those are selected, and then just export it with whatever name you're going to use. So like human, and then export that. And might want to come back in here and edit that. So we should probably save this as well. We're here. We're here. Oh, not the videos file. And this one, I'm going to call this a human.blend file to edit with. Save that. And then we'll probably need some sort of surface for him to stand on. I'm just going to do a new general file. Again, get that selection tool I like. Get rid of the default stuff. I'm going to add in I'll just make a big flat surface. And this is just me. The default cube is 2 by 2 by 2. So I always like to scale that down by half every direction, then hit Control A and reset that so that it's a 1 by 1 by 1 cube. And then when I come over here and scale it up, I don't know, 75 by 75, 75 by 75, that would give us a good, nice square surface to walk around on. And again, with some sort of texture. So I'm going to come over to materials. Could add just a color, but that might make it a little hard to see the character moving around. So instead of selecting the color, I'm going to select this thing right next to it and use an image. So from image texture, now there's an option to import an image. I think I'll go to the documents folder and use that tile from the 2D test. So for Pygame, there was this ground tile. Which will take a second to import, hopefully not too long. Switch over to material view. That actually came out pretty good on there. I might come back and play with some textures on that. It looks like it might texture up nicely for a ground surface without changing it to tiles or anything. What happens if I tile it? Oh, it did not like the tiled. They just all blend together. I'll go back to single image. But that gives us some sort of surface, and it's not just plain green, so we should be able to tell the characters moving there. So I'll save that in the same spot as let's call it land, as a .blend file. I'm going to come over to shading and make sure that default is set up the same way the principal BSDF is set to the surface of a material output, which again should be the defaults, so that shouldn't be an issue, but I think I'm remembering a couple blenders ago where that didn't want to export correctly in some cases. But as long as that's set up correctly, you can go to File and Export as a GLTF. And I'll call it land. Make sure UV materials are on, and export that. So that should be it for Blender. And if we come back over here, we see now we have these human and land, which will check the properties, are .glb files, which is close to what we want. So that gives us some 3D ones. We can open this in the viewer and see what the object looks like. Hopefully it'll open. Tick tock, there it goes. So we can see we have a basic 3D human object to work with, and for the test just have him move around and rotate the camera around him. Some basic 3D stuff. Skipping over the animations and things to make it quick. But these are GLB files, which still isn't what Panda3D wants. So Panda3D is actually set up to work with BAM files, but there's a nice little convenient thing here. If we go to where those files in Panda3D files installed, let's see, users, Chris, app data, local, programs, Python, way down through these folders. Here we go in library. Pip installs things into site packages. And down here under Panda3D, I think it's this one actually. Nope, not that one. Here we go. Panda3D, GLTF. Not sure if that was the one I was wanting or not. Somewhere in here, there's a whole lot of converters. Oh, here we go. We have converters. Egg to BAM, Egg2 to Maya 65, binary, some converters from eggs, converters from Maya into egg files, and a bunch of converters. And I scrolled through the list really quickly, but we have a GLTF to BAM converter. So we can use that to convert our files. So I'm in the right directory here. So that was one installed with all of the Panda3D stuff. So we can call the GLTF2 BAM. And remember, if you're in PowerShell, you have to say Python, and then the module you want is GLTF2 BAM. But in PowerShell, we can just type GLTF2 BAM. So do that conversion, and then the file we want to convert, so land.glb, we want to convert it to a land.bam file. And same thing for the other one, GLTF2BAM, because Panda3D actually wants a BAM file. We want human.glb to convert to human.bam. We did that conversion, and you can see we have those two BAM files here. So now with those files on hand, we should be able to add them into now that we have BAM files, we should be able to bring those right into Panda3D, our Panda3D game object, which we have an instance of, which just opens up. So to bring that in, I'm going to leave a little bit of space there so we can come back and do something. So we'll add to this object a self.land. And there's two steps to getting it into our scene. First off, we have to add it to a tree that tracks everything in the scene. So self.loader.load model, and we want to load land.bam, which obviously I put that in the same folder here to make that easier. Obviously you would need the whole directory if you have it somewhere more organized. which would definitely be necessary if there's more than 2 objects. Right? Those are going to add up quickly. And then so that puts it in the tree. And then there's a few other things that we probably want to mess with. So self.land, we have a set scale. That's important. We usually want to interact with that. And that add human button I have, which I will put a link to the GitHub so you can have that button or the script that button ran. And then have a add human button or script to do that quickly in Python, so you don't have to work with a cube or a sphere for a test model. So that is set to mention correctly. The whole library I'll link to in GitHub. All the proportions and scales and sizes are set like they would realistically for good starting points. So just bring those in, the scale it's set to. Then obviously we want to set the position, where's it going. So set POS for position. And I'll put this pretty much at the origin, but I'm going to bring it down a little. That way make sure the character stands on top of it, on top of the land, not right on it. So I'm going to go to 0, 0, and then -1 on the Z instead of just 0, 0, 0. And there's quite a few properties like that. But the 2 we need are we have to add it to the tree. And then once we have something on the tree, we can take anything on the tree and reparent it to self.render, which is one of the attributes of this showBase class that we inherited from here. So we put it onto a tree, and then we reparent it to the render attribute of the showBase class. And that's almost enough. Well, that's enough to show it. I'll go ahead and save this and run that. I'm still in this right directory, so call Python test1.py. And oh, okay. When I was preparing, it didn't bring in coloring, so I had to manually put in a light, but it appears to have brought the light in automatically. So there's some default camera controls. The right click zooms in and out. They're not very intuitive. Right click zooms in and out. Left click pans up and down, left and right, and holding the middle button and twisting that kind of tilts on different angles. So you can get to the view you want, but it's not very intuitive. So one of the things for this test is to reset the camera controls to that. So right click for zooming, middle click for tilting, and left click for panning is the basic controls, but they feel very non-intuitive and take some getting used to, that's for sure. Well, earlier when I was getting ready, it didn't put a light in by default, so I had to do that. So I'm going to, I think I'll go ahead and put an ambient light just to show it. So we can create a light called Ambient Light, and then we have to give it some sort of tag. Whoa, that is a weird looking string. That was a weird color. It's just a tag. I'll use the regular quote marks. And then that is in this other library of tools called Panda3D.core. And I'll just import all of them because we'll need quite a few of them at some point. So a whole bunch of our tools are there. But Ambient Light is one of the tools in there. And when I was getting ready, it didn't show the light. So if you bring it in and all you see is a big white spot, then that means there's no lighting in the scene. But for some reason, this scene does have lighting by default, whereas my prep one right before making the video did not. So I will go ahead and show this. So we want to set the color of the light, which is going to take in an RGB A triple, red, green, blue, alpha triple. So I'll do like 80% red, 80% green, 80% blue, and then just 100% on the alpha, so it's not transparent. Don't need transparency on the light. And then we need a reference to it. So I'll call it attach light, and that goes to our render object dot attach new node self dot light. And then once we have it attached there, we can attach multiple lights, obviously different point lights, diffuse lighting, spot lighting. There's several different options. I'm just going to go with the general ambient light for here. The only difference, so these three lines would be the same. The only difference is what type of light do we want? A spotlight, a point light, the different things like that. The other ones are kind of the same. And like I said, if you import it and you're just seeing a big white object, that means there's no light to see the materials. So I planned on including this because it did not show up in my prep one. But if you need to attach a light, there's the thing. So just ask for an ambient light, choose a color for it, create, attach the new node to the render object, and then once it's attached, do the render, and then just the set light method with that attached node, in case you need it. But it apparently came on by default here. Let's see if that made any difference. Nope, looks exactly the same. So I think it was, yeah, I think it had the ambient light. So maybe when I said it earlier, it went to a default setting of that or something. I'm not sure. But if you need the lighting, that's the words for the default. The light, and the only thing that changes is what type of light you're using. So now that we've got that in, let's add the human in. Basically the same way, since we already have the band file. So I'll call it human, and that's going to be self.loader.load model. So we have to load the model in, and it'll be human.bam. They included all sorts of converters, so there are converters, so that no matter what 3D software, modeling software you like to use, there should be a built-in converter that installed when you install Panda3D to convert it into a BAM file for you. And then once we have that, we can set a couple properties, like self.human.setScale, which those models are sized and proportioned everything about the animals and humans create correctly. So just bring in the 100% scale on everything, set a position, and I'm going to put this one right at the origin, 0, and the ground is like 1 unit below that. And whoops, that wasn't human, that wasn't land, that was human. Same thing here, self.human. It's in our tree, so now we need to take it from the tree and reparent it to self.render, the thing that actually does the rendering. So now if we run that again, I'll scroll out, there's our human. Looks like he's a little bit above the ground. If we rotate around, we can see we now have a couple 3D objects to start working with. At least enough to test the controller. And the default controls on using this on the mouse are very non-intuitive. I have a lot of trouble with them. You might get used to them some. Like right click and pulling down zooms in, and pushing up goes out. Panning is not so bad, just left click and drag left, right, up, or down. But the angles can be a little non-intuitive. But that gives us a couple 3D objects to start working with here and testing the controller.